be talking a little bit about audio system grounding and do a little bit of tips and tricks for troubleshooting grounding issues, as well as understanding where grounding issues come from in the audio system to begin with. Generally what happens in an audio system is you have different ground voltages from outlet to outlet. And this is the case whether you have your audio system on dedicated circuits or you have your audio system on a single circuit but different outlets. And so what happens is when you have parasitic capacitances and leakage currents in your audio system, there ends up being different ground voltages on each of those receptacles, and that creates a common impedance issue, a mismatch between your audio components, and that translates to a ground loop that in turn turns into noise. One of the best recommendations I can give you in terms of grounding your audio system is actually a little bit against what you'll hear in a lot of audio forums, is that you actually want to have your entire audio system grounded to a single receptacle. And that will help to eliminate any of those common impedance issues that you'll face when you have voltage differences between all of the different receptacles. Those voltage differences can be anywhere from a couple of millivolts to over a volt, and the larger it is, obviously the worse a ground loop you're going to experience. One of the other things that you see in a lot of audio systems is they actually, and for whatever reason a lot of audio dealers will recommend this, is you see a lot of cheater plugs. And people install a cheater plug thinking that it's actually the IEC earth ground that is causing the ground loop that they're hearing, and they think, okay, if I float the earth ground, I'm no longer going to have a ground loop. And one of the things you want to avoid, and one of the biggest dangers of floating the ground in that way, is when you have currents or a fault current. The design of the safety ground in the chassis is that in your wall panel at your breaker, the safety ground is tied to neutral. And so when you have a current mismatch between the live and the ground, it trips the breaker to prevent any kind of current flowing through the chassis or through a person. If you're floating that safety ground, then that ground current will flow not only through the chassis but your signal cables and find another path to ground. And so that's part of why you end up actually introducing even more noise with a cheater plug, just because the ground is going to find another path to travel down to earth. The other issue with that is that when you have a fault current and the signal has to travel through an interconnect, for instance, you're going to have a lot of current traveling through a cable that's not designed for that kind of current or voltage, and it can cause a fire, it can cause all kinds of dangerous issues that you want to avoid, especially since it's really not going to fix your grounding issues. So like I said, the first thing you want to do is ground your system to one receptacle, to one point. If you're using a power distribution system, it's very important that the internals of that system are grounded to a single point, so you try to keep the voltage differences between these outlets as close as possible. And this comes into play as an entire system, so you don't want to have half your system grounded into two different power conditioners because they're going to have differences in voltage. And one of the ways that the Colossus works here, beyond just being a grounding system, it's actually an active shielding system. And so one of the issues with audio equipment and noise is that the shield has to actually travel through a lot of the audio circuitry in your component and then to earth ground and then out to the wall. And so it has a fairly high impedance path to travel through and isn't as effective. So when you connect your device, whether it's a CD player or an amplifier or just a power supply, to the Colossus, you're actually creating a very low impedance path to ground for the shield, and that's very good for reducing noise quite dramatically. The Colossus functions very much like a single point ground for your entire system, but the filters and vibration dampening help to create an even reduced impedance path for ground to help to pull that noise away from your audio system, and it's hugely, hugely effective. Connecting these things, there's a couple of tweaks that I'll show you. First we'll show you how to connect the Colossus to your audio system, and it's fairly simple. I have a couple of our entry-level grounding cables here, but you can use bare wire. The first thing you want to do is find your component that you want to connect to it. This here is our GIient I Lite. It's our entry-level power conditioner for $2,000. If you're trying to ground it, and I generally would, there are different ways of connecting the GIient I and the GIient I Lite to the Colossus, so don't follow this pattern just for connecting the GIient I Lite. Just assume this is some other audio equipment chassis, and it's all going to be connected the same way. So you're just going to unscrew one of the screws on the chassis just a little bit, enough to fit either bare wire or the spade, and it's going to be easier obviously if you have a spade or a connector so the wire doesn't fray. And you're just going to screw it into the chassis so that it's tight. From there you're just going to connect the other end to the Colossus, and like so, and you're all set. And you can do the same thing for the rest of your system, and it's fairly easy to do that. The other tweak, obviously if you don't have a Colossus, and in this tweak I'll kind of give the disclaimer that sometimes it works, sometimes it makes the problem way worse, just from the standpoint that you're creating additional paths to ground that aren't necessarily lower impedance. But one thing you can try at home that can be of a huge benefit is grounding all of your chassis in this way to a single power receptacle. So what you would do is you would do the same thing like you were connecting to the Colossus, and you'll screw that in here. I don't know why I unscrewed it, but you know, I'm winging it. So here we go. And so what you're going to do is actually unscrew one of these receptacles in your wall. I generally recommend that you make sure that the power in your breaker is turned off in case you shove this into the live or something like that. And then you're just going to screw all of the wires into this one plug. So I have two wires here, and you wouldn't really do this with a high-end cable just because it'd be a waste of money. But generally this is the idea, and you would just use bare wire, anything that you have lying around. And of course the Colossus, you can use generic wire and it's going to be hugely effective whether you're using generic wire or high-end wire. The benefit of higher-end wires is basically that you are going to be able to increase the bandwidth of the noise that's being removed. This isn't going to work because these are too large for this particular device. Like I said, you want to use bare wire and connect it. The best way to do it would be to use bare wire and just grab one spade and twist the wire together at one end, and then attach the spade and then connect it to the single screw. It's very important that you only connect it to a single screw on a single circuit, otherwise you're going to defeat the purpose of the tweak. There's a couple other things that happen when you're looking at audio system grounding. When you have a common impedance issue between components created by voltage mismatches on the ground, you end up introducing noise currents that flow along the shield that are introduced into the signal cabling. When you're looking at a signal cable, and we'll pretend that this here is a signal cable, even though it's just carrying a single rail, but we'll pretend that this is carrying both let's say a data line and a shield. And one thing that happens is if the shield is connected at both ends with a ground wire, you end up having a ground loop that flows to earth and then back through the cable. And eventually that actually gets, that common mode noise turns into a differential mode signal. And that's why you start to hear that ground loop hum when you have a ground loop caused by these cables. There's a couple of ways to troubleshoot that kind of ground noise and still take advantage of the shielding properties. The first thing you can do is you want to connect the shield only at one end. Depending on which end that you connect it to, either the receiving end or the sending end, you're going to either help to avoid common mode noise, or you're going to be able to avoid RF noise. And so there's a couple of different things that you can look at doing. So if you connect it to the receiving end, you're going to have a much better result to filter out RF noise. Whereas if you connect it to the sending end, you're going to be able to filter out common mode noise. And a lot of times, obviously, you want to filter both types of noise and across a wider bandwidth. And so there's a technique called hybrid grounding or hybrid shielding. And what you actually do is you connect the shield at one end, at the receiving end is normal, and at the sending end you actually can capacitively couple, which means that you connect a capacitor in series with the ground on the sending end. And that gives you the benefit of both types of filtering without creating the ground currents along the shield. And this is an issue a lot of times. You'll see ground currents develop in a lot of audio systems. A lot of systems actually that are using power conditioning that has various types of active filters. So if you're using a transformer-based conditioner, if you're using a capacitor-based conditioner, or even an inductor-based conditioner, what happens is when you have any kind of common mode filter, so if you have an inductor-based filter, if you have a transformer or an LC filter, those common mode filters actually create parasitic capacitances that introduce a leakage current on the ground lines. When you have a leakage current on the ground lines, it creates a voltage mismatch between your circuits, and that's part of where ground loops come from. So if you're using a transformer, and every transformer is going to have this hopefully specified when you order your transformers, in terms of how much parasitic capacitance it has. And that will basically determine how much noise is that thing passing through it as a filter, but also how much is it passing to ground, and how much of a noise current is it creating on ground. The other misconception that I have seen is a lot of audiophiles think, okay, I need a dedicated ground for my audio system that's separate from the rest of my house. And so they install a ground rod for the rest of their system. The biggest issue with using a separate ground rod for your audio system is the same thing I talked about in terms of these receptacles. Soil is an awful conductor, and so it has very, very high resistance. And because those 2 points are connected in your home to ground, you're actually going to have the current flow through one ground rod and into the other before getting to the breaker panel. And this can create huge voltage mismatches that can actually increase your noise floor without the benefit of safety ground. You're going to want to read our article on grounding. There's a couple of links at the bottom of that article for further research. Of course, if you're having any issues troubleshooting a ground loop in your audio system, you're welcome to give us a call. We've troubleshooted 50 to 100 systems with ground loops and have every time been able to solve them. We have various devices that we can send to you for testing. And we're happy to help you. We have experience with any type of situation in terms of grounding. And that is our grounding video. Like I said, if you have any questions, feel free to shoot us an email, leave some comments on the video, and certainly watch the rest of our videos. We're going to continue to bring out videos probably every week or two. So keep your eyes peeled. Thanks for watching.